Hello students, we are solving a question from 22nd January, shift 1, JEE Mains 2026. It is from Electromagnetic Induction. The question says, XPQY is a vertical smooth long loop having total resistance capital R, where Px is parallel to Qy and the separation between them is small l. A constant magnetic field B perpendicular to the plane of the loop exists in the entire space. The rod CD of length capital L greater than small l and mass small m is made to slide down from rest under gravity as shown. The terminal speed acquired by the rod is. So in this question, as the rod slides down, it will gain motional EMF, right? Because it's moving in magnetic field. Let us assume into the board magnetic field. It's going to get motional EMF, and because of motional EMF it will draw a current I into the loop, and the current I will experience a magnetic force F magnetic, which is going to slow down the rod a bit. And finally, when the magnetic force becomes equal to the mg, that is when it will attain terminal velocity. Okay, so let's read what is written. As the rod slides down, it gains a speed and hence a motional EMF. This drives a current through the rod. Due to this current flowing in external magnetic field, it will experience a net upward force, right? The current driven in the rod will experience a force due to external magnetic field. Now, suppose you should remember the motional EMF is V vector cross B vector dot L vector. The positive terminal will come in the direction of V cross B. So clearly the side D becomes the positive terminal. This is D and this is C. This will drive an anti-clockwise current in the loop. Now, the direction of force acting on the rod will be in the direction of I into L cross B. If you check that, the force will act upwards, opposite to mg. Okay. Now the question is, if we would have assumed B to be out of the board, would the answer change? No. Still the ILB will act upwards itself. Why? Because in that case, end C would have been the positive terminal and it would have driven a clockwise current instead of anti-clockwise current, and in that case also if you check the direction of L cross B, it would have been upwards. Now applying Newton's laws of motion on the rod, downward force mg minus upward force ILB is equal to ma. Rearranging the term, you will get acceleration as g minus ILB by m. But what is the current I? The current I is motional EMF by resistance, which will be VBL by R. We can substitute this value into the acceleration equation and we'll get acceleration is equal to G minus V into L square B square by MR. You see, acceleration is a constant minus V into some another constant. So here, if the speed goes on increasing, the acceleration goes on decreasing. And when the particle attains terminal velocity, when the rod attains terminal velocity, acceleration must become 0. So putting acceleration 0, we get G should be equal to V into L square B square by MR, or the terminal velocity comes out to be mgr divided by L square B square. This is nothing but option